is 10-5 study guide page 2, exercise number 1. They give us an equation of a hyperbola and ask us to find a bunch of information and make a graph. I kind of make the graph as I go. I can tell this hyperbola has x first, so it's going to be a left and right. It's not shifted left or right at all. It's just x squared, y squared. So I know it's going to be centered right at the origin. The square root of 4 is 2. And the square root of 16 is 4. So I know 2 to the left and right is where I'm going to find the vertices. Okay? So when I'm going to make this graph, I go 2 to the right, put a dot. I go 2 to the left and put a dot. And I know those are where my vertices are. So that's at 2, 0 and negative 2, 0. When you go to write that as the vertices, you can write it out as 2, 0 and negative 2, 0. Or you can write it like plus minus 2, comma 0. That means positive 2, 0 and negative 2, 0. To find the foci, which is the next thing I'm supposed to find, we have to use the Pythagorean theorem. The a squared plus b squared equals c squared. That'll help us find the focus length. So I'm going to have 4, which is a squared, plus 16, which is b squared, equals c squared. 4 plus 16 is 20, equals c squared. Taking the square root on both sides, the square root of 20 equals c. 20 can be simplified as 4 times 5, and 4 is 2 times 2. So the 2's can be paired up, and the 5 gets left behind. So 2 root 5 is the focus distance, the distance between the center and the focus. Okay, so we know the focus is somewhere on the inside of each of these, so we'll just kind of put it in there, and we'll put it in over here. And I know that that distance between center and focus is 2 root 5. So I have the points 2 root 5, 0 and the point negative 2 root 5, 0. So for the foci, I can put those in the same way I put in the vertices, and I'll just say that it's plus or minus 2 root 5, comma 0. What's left is finding the asymptotes. Remember that the asymptotes is like a rise over a run. This 4 that we got by taking the square root of 16 is the conjugate radius. So I know that I need to go up 4 here and down 4 here in order to find this end of this conjugate radius. Okay, so you go up 4 and you go down 4. That's the end of the conjugate radius. So the slope there is up 4, right 2, y over x. So the slope for this one would be 4 over 2. And 4 over 2 is just 2. Since the slope is 2, the rise over the run, my asymptotes are going to happen at y equals plus and minus 2x. I actually do have to graph this one. This 4 up here gives me this magical point kind of up there. So that lets me draw in this asymptote that's going to go through the center and through that point, and it's also going to continue down in this direction. If I went down 4 and right 2, it would give me that point. That going through the center to give me this asymptote, going through the center and up there. Now I can go through my vertices, approaching the asymptote at the top, through my vertice, approaching my asymptote at the bottom, and then the same thing over here. So through my vertex, approaching that asymptote, and through this vertex, approaching that asymptote. So that would be a sketch, opening left and right. Got the vertices, the foci, and the asymptotes labeled.